Welcome to another video in our quantum physics series. If you're new here, we highly recommend you check out our previous videos to get a better understanding of the building blocks of the universe and the principles of quantum mechanics. In this video, we'll be exploring the fascinating world of quantum technology, from computing to teleportation. So make sure to hit that like button and subscribe to our channel to stay up to date with our latest content. The study of light is one of the oldest branches of physics. It has been studied for thousands of years, and even now there are still many unanswered questions about it. In this article, we will discuss some recent developments in quantum optics that could bring us closer to solving these puzzles. In this section, you will be introduced to some of the current advances in quantum optics. You will also learn about some of the most exciting applications of these technologies today. Quantum optics is the study of the interaction between light and matter at very small scales. It's one of those topics that can be difficult to explain, but it has many implications for how we see reality. Quantum computing is a subfield of physics that uses quantum mechanics to solve certain problems that conventional computers currently cannot handle. For example, quantum computers could theoretically outperform classical ones in solving problems related to encryption and artificial intelligence, AI. In practice, these advantages haven't yet been realized in real-world applications. However, there are still many practical applications being researched today. For instance, designing new drugs based on their molecular structure, creating more efficient solar cells, modeling climate change. Patterns over time periods longer than human memory capacity allows us to remember them. Beams of light as quantum particles. In quantum physics, light is a particle, and at the same time it can be described as a wave. This may seem like an oxymoron, but it's not. When you look at light in your eyes, it behaves like both particles and waves simultaneously. The reason for this is because of its wave-particle duality. The wave function of an electron is just one example of this phenomenon. See the Beatty-4 protocol. The Beatty-4 protocol is a quantum key distribution protocol developed by John Cramer. It was designed to be used over a short distance of up to 3 km, which is sufficient for secure communication between two parties who are separated by more than 2 kilometers. The Beatty-4 protocol uses entanglement to ensure that no one else can gain knowledge of the key being used in this exchange. Entanglement. What is entanglement? It's a very strange phenomenon in physics that happens when two particles are linked together. For example, if you have two photons at different locations in time, even if they are separated by a large distance, then they can become entangled with each other by sharing information between them. This means that if one photon changes its direction of polarization, the direction in which light waves vibrate, then the other photon must also change its direction of polarization at exactly the same time. In this way, no matter where on Earth you are located or how long ago your measurement took place, these photons will always be able to interact with each other even though they're many miles apart. In quantum computing applications, such as encryption and teleportation via Bell Labs' teleportation system for quantum entanglement, researchers use entangled pairs of photons to transmit information securely over long distances. Superposition. Superposition is the ability of a particle to exist in 2 or more states at the same time. It's a central feature of quantum mechanics and has been used for decades to encode information, teleport information, and build quantum computers. For example, when you look at your computer screen, what do you see? A bunch of pixels? The color red and green lines that make up your screen. But what if someone told you that these pixels were actually tiny particles like electrons? That could be in one of 3 different positions: 0, 1, or 2. The result would be an image showing what position each electron was based on how many times it was measured over time. See Figure 4. This new way of viewing reality opens up countless possibilities for how we can understand our world better, and maybe even change some things about it. Quantum algorithms. One of the most exciting developments in quantum computing is its use of quantum algorithms. These are programs that can be used to find solutions to certain problems in a much more efficient way than classical computers. This can be useful in many areas, including cryptography, simulation, and physics research. Quantum algorithms have been used with great success by scientists working on quantum computing projects such as IBM's Q Experience Center at the University of Waterloo and Google's Bristlecone Lab, eQuantum Computing. 7 Quantum Key Distribution. Quantum key distribution is a method for sending information over an insecure channel. This process uses the laws of quantum mechanics to encrypt data, but it does not rely on any specific technology. KK can be used as part of quantum cryptography, which is a type of encryption that uses advanced concepts from quantum mechanics. The goal in this case is to make sure no one can eavesdrop on your conversations or steal your secret information by using their ability to see into the past or future as well as faster than light travel. Quantum optics is a rapidly growing field with many applications in the future. Quantum optics is a rapidly growing field with many applications in the future. It's a subset of quantum physics, which studies the behavior of light and other particles. Quantum optics involves studying how light interacts with matter at different length scales, from atoms to planets, to understand how these interactions change when you move away from classical physics, or even just move your head slightly in relation to something else, like gravity. We have covered a lot of information in this post. Quantum optics is a rapidly growing field with many applications in the future. It may seem complicated at first, but once you understand the basics, it can be easier to apply them to your own project. In addition to this blog post, you should also check out some of our other resources on how quantum mechanics works. Thank you for watching. I hope this video has shed some light on the exciting advancements in the field of quantum technology, from quantum computing to teleportation. If you enjoyed this video, please consider subscribing to our channel, leaving a like and sharing it with your friends. We also appreciate any comments and feedback you may have. Don't forget to stay tuned for the next installment in the series. Thank you again, and see you in the next video.
You can pray.